Hello students, welcome to this lecture in the course of Basic Instruments. Up to now, we have discussed basics of measurement, error propagation, uncertainties, difference in precision and accuracy of a measurement, ethical consideration of measurements, and we also talked about safety considerations. As promised in previous lecture, we are starting next unit of this course. In this unit, we are going to talk about optical instruments. So let me introduce this unit, what we are going to deliver, and the students who are following it, what they can expect from it. So this unit is designed for undergraduate physics students, and it aims to provide an introduction to optical instruments. We are expecting 10 lectures for this unit, and it will provide the students fundamental principles and application of various optical instruments. So this unit starts with an overview of optical instruments, including their historical developments, basic components, and application in science and technology. Here we will study lenses and mirrors, including their properties, types, and applications. And we will also discuss about optical fibers, including their properties, modes, and application in communication systems. So this is a different topic. We will put separate 1 or 2 lectures on this optical fibers. In continuation with lenses and mirrors, we will also talk about the spectrometers, polarizers, and filters, including their principle of operations, types, and application in various fields of science and technology. We will also cover interferometers, diffraction gratings, including their principles, types, and application. Also, we are going to discuss microscopes and telescopes, including their basic principles, types, and application in imaging and observing the microscopic and astronomical worlds. Here we will also talk about lasers, radiation sources, and detectors, including their principles, types, and application in modern science and technology. So we will conclude our a kind of look for its application. The instruments we are discussing the unit in final, we will discuss its application in various fields like medicine, telecommunication, astronomy, and spectroscopy. So it will provide a comprehensive introduction to optical instruments, and it is essential for undergraduate physics students interested in pursuing career in optics, photonics, or related fields. So let me introduce optical instruments for sake of completeness. Optical instruments are devices that use light to observe, measure, or manipulate objects and material. So all such devices, we call them optical instruments. There is a long history dating back to ancient civilizations such as Egypt and Greece, where lenses were used to magnify small objects. In 17th century, development of telescopes and microscopes revolutionized the way we observe and study the world around us. Galileo invented first telescope in 1609, while as Antony is credited with creating first practical microscope in 1674. Over time, advance in optics led to the development of more sophisticated optical instruments, including spectrometers, polarizers, interferometers, and lasers. These instruments have found numerous applications in science and technology, including medicine, astronomy, telecommunication, and material science. So, with this brief introduction of optical instruments, let us go to the very basic instrument, basic component of optical instruments, and we'll uh, talk about that. Let us also talk about with some properties of light, what we understand at this stage. We are introducing it to very basics, and so the basic components for most optical instruments include a light source. So there is a light source. There is a light source in optical instrument. Lenses and mirrors. It is to focus and manipulate light. A detector to for measuring light that passes through the sample or object, and display a recording device to record and interpret the data. They have enormous application in science and technology. Like microscopes has been extensively used in biological sciences to observe cells and microorganisms, while telescopes allow us to observe distant galaxies and stars. Spectrometers are used to analyze composition of materials, while polarizers and filters are used to manipulate light for various purposes. In our daily life, a lot of the optical instruments, their components we use. In telecommunication, optical fibers are used to transmit information over long distances with minimal loss of signal. Lasers are used in variety of applications including surgery, welding, and material processing. So overall, we can say that optical instruments have a profound impact on our ability to observe and understand world around us, and their application continue to expand as technology advances. So let us talk about light, some properties of light. Let us try to get an idea about it. So light is a form of energy that travels in form of waves or particles called photons. So it has dual nature. It also shows wave character as well as particle character. And it has been verified from many phenomena. So at this stage we say that light is wave as well as particle. It is an electromagnetic radiation that is visible to human eye when we call light. So electromagnetic spectrum is a big range of frequencies from starting to gamma rays to radio waves. There is a part of this spectrum for which our eyes are sensitive. That means it is visible to human eye, and it can be described in terms of properties such as wavelength, frequency, and polarization. So let us talk about some basic phenomenon associated with this light. So one other basic phenomena is reflection. Reflection is the process by which light bounces off a surface and changes direction. When light encounters a reflective surface, such as a mirror, it reflects off the surface and forms an image. The angle of incidence, the angle at which light hits the surface, is equal to the angle of reflection, the angle at which light bounces off the surface. So without using equations, I'm just trying to describe this phenomena to you. for an basic understanding. These lectures could be useful for physics student as well as anyone who is interested to learn it. So I'm keeping it to very basic level. We will go into the details as much we proceed further. So the another phenomena with light is refraction. Refraction is the process by which light bends as it passes through a medium, such as air, water, or glass. The amount of bending depends on the angle of incidence, the angle of refraction, and the properties of medium through which light is passing. When light passes through a medium with different refractive index, such as when it enters a glass prism, it can split into its constituent colors, a process known as dispersion. So here in this slide, we, after defining what do you mean by light, we have briefly described three phenomena associated with it: reflection, refraction, and dispersion. So here, the dispersion is here. You can see three pictures. One by one, all these three phenomena are described. We'll come into it. Before going to it, let us go into bit more description of the phenomena of dispersion, what it is and how it happens. Dispersion is the process by which light is split into its constituent colors when it passes through a medium with different refractive index. When it passes through a medium with different refractive index and light is split into its constituent colors, this process, this phenomena is called dispersion. This is because the different colors of light have different wavelength and they bend at different angles when passing through a medium. This results in a spectrum of colors ranging from red to violet. So you can see these fundamental proper concepts of light and properties are essential in understanding the behavior of light in different optical instruments. So since we are talking about optical instruments, to understand behavior of light here, we need to have some basic concepts and properties of light. We have to understand it. So the instrument we are interested in, lenses, mirrors, and prisms, they are instrument, or we can say component of the optical instruments. So you see in the first cartoon, this is sun and light is falling on this tree, and here is some human is observing it. So whatever we see in जो कुछ भी हम देखते हैं, it is because of the light is reflecting from that surface to our eyes. So this tree is visible to us because the light from sun is reflecting from this tree and it comes to our eyes. So the reflection phenomena is responsible for whatever we can see around us. Then in second picture you see there is a glass and some liquid is filled here, and if you put pencil here, so if you see this from outside, it looks like that this pencil is bent in this. So this is because of refraction of light. The light rays, whatever we are seeing, it comes, we see it because of reflection. So whatever we are seeing here, it is not a reality, but this is because of refraction. ऐसा नहीं कि ये पेंसिल मुड़ गई है, ऐसा हमको दिख रहा है क्योंकि ये जो दूसरा मीडियम है इसका रिफ्रैक्टिव इंडेक्स दूसरा है और यहाँ पे लाइट बेंड हो गई. ठीक है, क्यों बेंड हो गई? तो लाइट बेंड्स इनवर्ड्स बिकॉज द स्पीड ऑफ लाइट इज स्लोअर इन द वाटर. हम लोग बेसिक इंस्ट्रूमेंट का कोर्स कर रहे हैं तो हम बहुत ज़्यादा उसकी प्रॉपर्टीज में ना जाके हम इंस्ट्रूमेंट पे फोकस करना चाहते हैं, इसलिए हम बहुत ब्रीफली इन बेसिक कंसेप्ट को इंट्रोड्यूस कर रहे हैं. This is a glass prism. Here if you put a white light, here we can see the spectrum from red to violet. So this is because of the phenomena of dispersion. Okay, so I think now we are familiar with three basic phenomena of light, three basic properties of light, that is dispersion, refraction and reflection. Now we can talk about lenses. What are the lenses? So lenses are basically transparent objects. Transparent object, कोई object transparent कब होता है? Think about it. So lenses are transparent object. मतलब लाइट उससे आर पार जा सकती है. लाइट के लिए वो कोई भी it's not opaque to light. So made of glass or plastic, means it could be made of different materials which has to be transparent, and that can refract light to focus it or diverge it. So what are lenses? Lenses are transparent object made of glass or plastic that can refract light to focus or diverge it. Lenses mainly दो तरह के होते हैं जिनको हम लोग कहते हैं कॉन्वेक्स लेंस एंड कॉनकेव लेंस. कॉन्वेक्स लेंस क्या करते हैं? लाइट को कन्वर्ज करते हैं या फोकस करते हैं, तो हम लोग इसको कह सकते हैं कन्वर्जिंग लेंस. एंड कॉनकेव लेंस डू द अपोजिट थिंग, that is diverging. So they are also known as diverging lenses. So convex lenses are thicker in the middle than at the edges, and they converge light rays toward a single point that is known as focal point. When parallel light rays passes through a convex lens, they converge and meet at the focal point, forming a real image. The distinct distance between lens and focal point is known as focal length. This is a property of lens, and the position and size of image formed by convex lens depend upon the distance of the object from the lens and the focal length of the lens. तो लेंस का एक फोकल लेंथ इसका एक पैरामीटर है, और जिसका हम इमेज देखना चाह रहे हैं वो ऑब्जेक्ट कहाँ पे रखा है, ये चीज मायने रखता है कि वो इमेज कैसे बनेगा, कहाँ बनेगा. दूसरे जो लेंस हैं कॉनकेव लेंस, ये कैसे होते हैं? ये बीच में थिनर होते हैं और एज पे थिकर होते हैं, एंड दे डाइवर्ज लाइट. तो ये क्या वो कन्वर्ज करते हैं, ये डाइवर्ज करते हैं. When parallel light ray passes through a concave lens, they diverge and appear to come from a virtual focal point which is located behind the lenses. The image formed by the concave lens is always virtual. वहां कैसा इमेज बन रहा था? रियल. यहाँ पे कैसा बन रहा है? वर्चुअल. एंड स्मॉलर देन द ऑब्जेक्ट. द पोजिशन एंड साइज ऑफ द इमेज फॉर्म बाय द कॉनकेव लेंस also depend upon the distance of the object from lens and the focal length of the lens. So we can say that lenses are of two type, convex lens, concave lens, और इनसे एक डाइवर्जिंग है, एक कन्वर्जिंग है, और इसमें एक पैरामीटर है फोकल लेंथ. वो किसी भी लेंस के लिए महत्वपूर्ण है, और कोई ऑब्जेक्ट का इमेज कब कहाँ बनेगा ये डिपेंड करता है कि वो उसकी पोजीशन कहाँ है, वो कहाँ पे रखा है लेंस. हियर वी कैन सी दिस विद पिक्चर. दिस इज कॉन्वेक्स लेंस. जैसा हमने बोला कि ये बीच में थिक है और एज में पतला है. तो ये क्या कर रहा है, यहाँ से अगर पैरेलल लाइट रेज आ रहे हैं तो फोकल पॉइंट पे ये कन्वर्ज करा दे रहा है, इसलिए इसको कन्वर्जिंग भी कहते हैं. और ये दूसरा लेंस देख रहे हैं, ये कौन सा लेंस है? कॉनकेव लेंस है. ये बीच में पतला है और एज पे मोटा है. ये क्या करता है, अगर हम लोग पैरेलल रेज डालें तो ये उनको और डाइवर्ज कर दे रहा है. दैट इज व्हाट वी टॉक्ड अबाउट. एंड हियर you can see there are few different type of lenses. तो ये जो तीन लेंस शुरू के हैं इनको हम कन्वर्जिंग लेंस कह सकते हैं, और जो ये लास्ट के तीन लेंस हैं इनको हम डाइवर्जिंग लेंस कह सकते हैं. तो इसमें हम लोग देखेंगे कि इनके दो फेसेस है. इसके दोनों फेस एक जैसे हैं, तो इसको हम लोग डबल कॉन्वेक्स कहते हैं। इसका एक फेस प्लेन है, एक में कॉन्वेक्स है, तो इसको प्लेनो कॉन्वेक्स लेंस कहते हैं, और इसको कहते हैं कन्वर्जिंग विनिसियस। ऐसे ही इनके भी नाम हैं। द फॉर्मेशन ऑफ इमेजेस बाय लेंस इज गवर्न बाय प्रिंसिपल ऑफ रिफ्रैक्शन। जो हम लोगों ने अभी रिफ्रैक्शन सीखा था, उस पे ये डिपेंड करता है। पूरा जो इसका ऑपरेशन है, इमेज कहाँ बनेगा, कैसे बनेगा, ये जो रिफ्रैक्शन के लॉ है उस पर बेस्ड है। और थिन लेंस इक्वेशन, एक लेंस इक्वेशन होती है जिससे हम ये बता सकते हैं कहाँ पे इमेज बनेगा। Refraction is the bending of light rays as passes through a lens, and it depends upon the refractive index of the lens and angle of incidence of light. लाइट किस एंगल से पड़ रहा है और जो लेंस है उसका रिफ्रैक्टिव इंडेक्स क्या है, ये कितना बेंडिंग होगा, इसके बारे में भी बताता है। The thin lens equation relates the focal length to the lens and distance of the object and image from the lens. The behavior of light in lenses and formation of images have important application in various optical instruments such as cameras, microscopes and telescopes. तो ये जो इंस्ट्रूमेंट्स हैं वहाँ पे ये बहुत बेसिक कंपोनेंट हैं, ये लगभग सारे जगह यूज किए जाते हैं। तो ये ऑप्टिकल इंस्ट्रूमेंट के कंपोनेंट्स की तरह हम इनको अभी देख सकते हैं। द अंडरस्टैंडिंग ऑफ प्रॉपर्टीज ऑफ लेंसेज एंड देयर बिहेवियर इन डिफरेंट सिचुएशन is essential in designing and using these instruments. So today we have just introduced this unit and we talked about some introduction of optical instruments and we talked about lenses and different type of lenses. So today we are stopping here. We'll go further in coming classes. Thank you so much.